When directions ask you to name all sets of numbers to which each real number belongs, you are trying to take the numbers and identify which subgroups that they belong into. So remember, natural numbers are numbers that start at 1 and they continue on. 1, 2, 3, 4, 5, 6, so on and so forth. Notice that if we keep counting those natural numbers, we will eventually hit 12, which makes 12 a natural number. 12 is also a whole number because if I start counting at 0 and I go 0, 1, 2, 3, 4, 5, 6, so on and so forth, I will also run into 12. So 12 is also a whole number. Integers are both the negative and positive whole numbers, or whole numbers in their opposites. And if you look on the number line, 12 will also be continuing on the number line as well, which makes 12 an integer. 12 is also rational, and you can look at that one of two ways. You can look at that as it's a terminating number. If I want to write that as a decimal, I can write that as 12.0. Or you could look at it as 12 is a fraction, 12 over 1. So whatever way you look at it, that makes 12 a rational number. Whereas if I look at the square root of 25 and put that into my calculator, the square root of 25 is 5, which means I need to be classifying the number 5. Well, 5 is a natural number because if I continue on and start counting, that makes it natural. 12 is also a whole number because if I go 0, 1, 2, 3, 4, 5, I actually hit 5 there. 12, square root of 5. Square root of 25 is 5. 5 is also an integer because it's both the negative and positive whole numbers, and it would be on the number line as well. So 5 is an integer. And 5 is also rational because once again, it is a terminating decimal and or it is a fraction. I could write that as 5 over 1. So that makes this number rational. Whereas if I take the square root of 13 and put that into my calculator, the square root of 13, is this nice long decimal that goes into the edge of my calculator. Now note that if a number goes all the way to the edge, that does mean that it will continue on forever. Is there a pattern? No. So when we go to classify the square root of 13, is it a natural number? If I start counting at 1 and I go 2, 3, 4, 5, 6, will I ever say this nice long decimal? No. Whole numbers, if I start counting at 0, 1, 2, 3, 4, will I ever say this decimal? No. Is it an integer? No, it is not a dot that's on a number line. Is it rational? No, it does not repeat or terminate, which then makes it classified as an irrational number. Irrational numbers are non-terminating decimals and non-repeating decimals. It is also a non-perfect square because 13 is not a perfect square. So this number is irrational. I will do one more, and I will do number, I'll do number 6, okay? 9.3 with a bar above it means that that 3 repeats. So it would be 9.3, 3, 3, and so on and so forth. Is 9.3 repeating natural? No, it is not a counting number. Is it a whole number? Well, all I did was add 0, and it is also not in that group of numbers. It is not a number on the number line. 9.3 does not fall specifically on the number line. Is it rational? Is it either a fraction? Is it a terminating decimal or a repeating decimal? Yes, it is a repeating decimal, which makes that rational.